Welcome, everybody. In this video, I want to talk to you about the different forms of equations of lines and also how we can write equations of lines given information. So the first thing I want to point out is that there are three forms of lines we tend to talk about, or like styles. Now, of course, you can write lines more than just these ways, but these are the ones we tend to talk about and have a name for. And the interesting thing is that the same line can be written in all of these different forms. So for instance, in the example here, and I'll show you why in 1 minute, these are actually all the same line. If I were to graph each of these, I would get the same points on the line. It'd be the same exact graph, but they're written in different forms. The first example here is written in what's called point slope form. Now, the general form for point slope form looks like this. It's y minus y1 equals m times x minus x1. And the key thing here is that you have a few pieces, right? M is still your slope. So you see that right there. And then what happens is that x1 comma y1 is any point that's on the line. So this x and y, and you can see it here, are variables in the problem, and the other piece gets filled in. So you need to know one point on that equation in order to use this form. And this is what point slope form looks like. Now, the interesting thing, though, is that we could clean this up, right? So I could use distributive property and multiply through. I get y minus 3 is equal to 2x minus 2. And then when I add 3 to both sides, what happens is I wind up at this form. So by cleaning up the point slope form, I end up in the slope intercept form. Now, the slope intercept form in general looks like this. That's our mx plus b form, right? So m is still our slope here. And then what happens is the point 0b is particularly the y-intercept, right? So you also know one of the points on the graph, but it has to be the y-intercept that you know. And then the third thing that we can do is we also can write this in what's called standard form. Now, standard form is used more so as a sort of ending example, kind of. So it's a nice form to write your final answer in if it asks for it. And we do use it a lot in modeling as well. If we're trying to do like a very large, real world application example where we have multiple equations, we do often write sometimes it in standard form. I would say your first two forms are probably the most common, but standard form is used a lot as well. So how did we get to standard form? Well, basically in standard form, what happens is you want your variables on the same side. So you have ax plus by equals c. And again, the big thing here is that your variables are on the same side and your number or whatever this constant is on the other. So if you notice in these two forms here, you have the variables on one side and you have just the number on the other. So how can we do that? Well, there's different ways you can do it. A lot of people like to leave their x term positive. So if that's the case, what you would do is you would bring the y over here and you'd bring the 1 this way. So you'd end up subtracting y from both sides and subtracting 1 from both sides. So you end up with -1 is equal to 2x minus y. And that's this form here. I just switched the two sides. Now, the other thing you could do instead is you could have just brought the x over to the left by subtracting 2x to both sides, and that's how you can get this form here. These are actually the same exact answer. It's just that you would have to multiply this one through by -1 to switch the signs all around. So these are actually both considered correct, although I would say most people like to have the leading term positive when possible, but it's not incorrect necessarily to have it negative. So these are both correct. They are the same as well. If I multiply the first one through by a -1, I would see it would match with the second one. So these are all the same equation. It's all the same line. They just look differently. And I always the way I think of this is with how I dress, right? So how I dress when I go to work is different than how I dress if I go to the gym, which is different than how I dress if I'm just going out, to eat for the night, which is different than how I dress if I'm going to a wedding, right? So I'm always still the same person, right? I am not changing, but my appearance is changing each time, right? And that's what's happening here. So this is the same line. It's the same core fundamental idea, but it's just that the outer appearance is slightly changing each time. So these forms are all interchangeable and you can go from one to the next, depending on, the problem and what you need. Now, why do we need multiple forms? And again, they both have their pros and their cons. I would say that, slope-intercept tends to be our most popular. We really love slope-intercept because it gives us a lot of information right away. It gives us the slope and it gives us the y-intercept. It's easy to graph. It's easy, again, to find a lot of information out just really, really quickly. So that probably tends to be the favorite. However, point slope form can be particularly helpful as well, particularly when we start writing our own equations. And like I said, standard form we tend to use mostly as like a final answer form, or more so in modeling. It is really helpful if I am going to have multiple equations within one problem. Then this form tends to be nice because it just keeps like your x's in line, the y's in line, and just stays nice and organized. So what I want to do next is I want to now show you how you can write your own equations, given some background information and using the different forms. All right, so typically we're used to somebody or a textbook or someone or something giving us the equations already, right? We get the equation and then we find points and then we graph it and we do things like that. Here we're going the opposite direction. I'm going to give you some basic information and have you create the equation on your own. Now, when you're writing equations, you need two things. The first thing that you always need is some sort of slope, or maybe you can find the slope. And the second thing you need is you need a point. Any single point. Now, there's more than just this method for writing equations, but this is the one that I prefer, that I think is one of the easier ways to do it. So what I would do then is, depending on my point, if I knew particularly the y-intercept, so that's the point 0b, then what I would do is I would use the y equals mx plus b form to find my equation. And what you're going to do is you're going to plug in for m and you're going to plug in for b, and it's actually going to be a pretty quick process, and I'll show you an example of that in just a couple minutes. If you don't have the y-intercept though, so let's say I just have a point, x1 comma y1, just some point, then what I do recommend here is typically to use the point slope form. So y minus y1 is equal to m times x minus x1. And what you're going to do is you're going to plug in the point, so x1, y1, and the slope. Now, often when we do this form, we will likely clean this up to the slope-intercept form or to standard form or something else. So just make sure you read your questions really carefully and how they want your final answer. This is a nice form to start with, but we don't often leave it as our final answer. We usually clean it up and multiply through and things like that. Now, there are different ways to do this, like I said. So some students do learn how to take any point and plug it into this formula and solve for b. So if you already know a different technique, you're more than welcome to use it. This is a style that I'm going to focus on in this video. But again, there's so many different strategies in mathematics. So if you've learned something that works for you over the years, and again, you understand it and can demonstrate that, right? Show your work or explain it, then you should go ahead and feel free to use it. All right, so let's look at an example. Find an equation of the line with slope 1/4 and containing the point 0, -3. Okay, so again, we're writing an equation of the line. So find an equation, write an equation, they all mean the same thing. So the two things you need to get started is you do need a slope and you need a point. Now this problem's kind of nice because they do give us everything right away. I can see my slope here is 1/4, And I can see the point they give me is 0, -3. Now I want you to notice that in particular, this happens to be the y-intercept. If you forget, how do I know it's the y-intercept? Because the x value is always 0. So if the x value is 0, then I know it has to be the y-intercept. Otherwise, it is not the y-intercept. So in this case, the b value is -3. Now, when I know the y-intercept, then what I'm going to do is I'm going to use this form of an equation right here. So I'm going to write the form out, y equals mx plus b. And what I'm going to do is I'm going to replace the m with my slope and the b with my intercept. So I have y is equal to 1/4 x plus -3. And this is fine, or we can write this as 1/4 x minus 3. And you're lucky here, you're done. So when you have the y-intercept, it is very, very quick to get that equation. You're just plugging in for m and b. There's really no work to do there. If you want to clean up, a tiny bit, you can, but otherwise that is going to be your equation. All right, let's do another example. Find an equation of the line with slope -2 and passing through the point -1, 5. Again, we're writing an equation of the line. So the two things I need are always going to be slope, which here I do know it. It tells me my slope is -2. And I also need a point, which in this case, they're telling me is -1, 5. Notice that the x value is -1. It's not 0. So this is not the y-intercept. So if it's not the y-intercept, I recommend, or the way I do it is I use this formula instead. And what you're going to do is you're going to replace the y1, the m, and the x1. So what happens is that point -1, 5, the first value is your x1 and the second value is your y1. So the equation becomes y minus, y1 is 5, m is -2, x minus, and x1 is -1. Just watch out for those double negatives there. So there's always minus signs in this formula. And then if you have a negative, it does get a little bit tricky here. So that is going to change to a positive. So this becomes y minus 5 equals -2 times x plus 1. And then we're going to actually clean this up. So let's write this in both the slope form and the standard form. We'll just practice both here. So I'm going to start by multiplying through. I get -2x minus 2. I'm going to add 5 to both sides, combining like terms. And I have -2x plus 3. And this right here is my slope intercept form. So if the question just asks you to find the answer and write your answer in slope intercept form, then that's what you're looking at the final stage there. If they want it in standard form, though, remember in standard form, you want your x and y on the same side. So if I do want this in standard form, what I would do is I'd want to bring this x to the other side over with the y. I'd have 2x plus y equals 3, and this would be my answer in standard form. So remember, slope-intercept form is the mx plus b form, and in standard form, you have your variables together on the same side. So both of those are typical ways to write final answers, and you just want to really read your text carefully to make sure you know how to put your final answer. In the rare case it does say to leave it as the point slope form, then that is this right here, or I guess this one, probably these two. Right, so those are both point slope form. This one's the cleaned up version. But again, rarely do we leave our final answer in that form. All right, let's do another one. All right, so find an equation of the line through 2, 5, and -3, 4. Again, equation of the line here. So what do we need? I need a slope and I need a point. All right, now I have plenty of points, but I don't have a slope. However, these should not be trick questions. You should be able to find the slope. So what I want to recognize here is that I actually can find my slope by using that y2 minus y1 over x2 minus x1 formula. So in this case, I can plug in my values. So I'm going to let this point be x1, y1, and this one be x2, y2. It doesn't matter which one you pick in each case. So I would have 4 minus 5 in the top, and then -3 minus 2 in the bottom. I end up with -1 over -5, or just positive 1/5. Those two negatives will cancel. So I do have a slope. I just have to work for it. Now, the other thing that's interesting, if you have more than one point, you can pick. So I tend to pick whatever I think is easier for me. I like positive, so I'm going to go with 2, 5 here, but you could also go with -3, 4. Now, this would be a great exercise to do it twice, one with each point, and just see that you actually do get the same answer in the end. So if you have some extra time, which I know is rare, and you want to do a little bit more practice, do it first with 2, 5 with me, and then pause the video and try it again with -3, 4, and you should get the same equation in the end. If you don't, then you have a mistake somewhere. I'm going to notice too that neither of these points are the y-intercept. If I had the y-intercept, I always pick the y-intercept because it's the fastest way to do it. I don't have that here though. So I'm going to use 2, 5. This is again not the y-intercept. So I'm going to go ahead and use that point slope formula instead. So in this case, oops, make that a minus sign. My y1 is 5. My m is 1/5. And my x1 is 2. So I have y minus 5. I am going to distribute this through first. So I end up with a 1/5 x minus 2/5. Now, don't forget when you multiply across, 1 times 2 is 2, and 5 times 1 is 5. You're not multiplying the 5 diagonally or anything like that. Now, I don't really like fractions, so at this point, I am going to cancel everything out by multiplying both sides by 5. So you end up, again, distributing that to all pieces. So I have a 5y minus here, 25. Here, what happens when I distribute to both pieces is those 5s end up canceling. So we end up with 5y minus 25 is equal to x minus 2, right? There's a 1x there, and there's a 2 left here. Then I can go ahead and add 25 to both sides. So I have 5y is equal to x plus 23. Now, let's say we want to write this final answer in standard form. So that means I want the x and y together here. I can bring the x to the other side and subtract it. So I have -x plus 5y is equal to 23. And this is actually correct. So you're done here. If you don't like that negative, though, what you could do is you could multiply everything through by -1. So that would give you a positive x, a -5y, and a -23. So, either answer is actually correct here. But that would be how you would write it in standard form. If you wanted to write it in slope-intercept form instead, you would have to divide everything by 5 to get the y by itself. So you'd have x over 5 plus 23 over 5, or x equals 1/5 x plus 23 over 5. There is always a factor of 1 you can use there. So this way is standard form. This is your slope-intercept form.